Okay, this innermost scale here, inside of the log scale, is a very long spiral. And it starts way over here on the inside at 1.0015. And it goes all the way around here, 1.014. Jumps up again here, 1.015, spirals all the way around to 1.15. Jumps up here to 1.16, spirals all the way around to 4. There's 4.1, goes all the way around here. M is 1,000. So here's 1,000, 2,000, 10,000, 100,000. There's 1,000,000. You can use this to raise things to weird powers. Here's 1.07. Now you may notice if you put the cursor over here and you read the 2 here. So if you ask what is raised 1.07 to what power is 2, because this is, you jumped exactly up, it's equal to being on this cursor. That's a factor of 10. So you read 1.01, so it's 1.0716, and it's actually about 1.072. And what that is if you take 1.07, say 16 to the 10th power, multiply it by 10 times, you'll get 2. And that's like for interest calculations. You may have heard of the rule of 72. And it's a very close approximation where you take the number of years and divide it by the interest rate. And the factor is 72. That's the number of years. It'll take the double. So if you take 1.07 here, 1.007, like 0.7% interest on here, it's very close. If you raise it to the 100th power, you get a doubling. And what you do is you go through and use on here, let's say that was 1, and I wanted to put this on here 13 years. I could go through and slide this back as a unit and put this on 1.07. So if I took 1.07 for 10 years, it's close to a doubling too. But in 13 years, it's equal to 2.41. So what you have to do is you have to know what range your answer is so you don't get screwed up by an exponent. So as a check here, let's just do a doubling, 1.2. Or something times itself. If I take something like 1.1, put it on here, 1.1 times 1.1, you get over here 1.02. Excuse me, 1.211. That's the same as going over here just for multiplying. 1.1, put this on the C scale for 1, 1.1, slide this over. 1.1 times 1.1 is 1.21. So normally when you're using a calculator like this, you're just doing simple things like multiplying, dividing, and you kind of get you can get screwed up by not knowing where your exponent is, but you do get a kind of a sense of feel for the size the numbers need to be, so you don't get carried away with, too many digits, nonsense digits as we used to call them. So if you go through here and like I did in the previous calculation, if you want to know 120 times the square root of 3, you can go through here and put this on a 1. You could let that be 10 volts, 100 volts. Let's say that's 100 volts. You could put this on the 1.2 and that's 120 volts. Now, I'm going to move the large cursor and these are moved together. Now I'm going to go look here for the square, which is A scale. So over here is 3. Square root of 3 is 1.73. I'm going to put this cursor on this bottom cursor here. So I'm multiplying the factor of 1.2 times the square root of 3. And then you get 208 volts up here. So obviously you have to know at what range your answer is. That was this previous thing where I had what you call a high leg delta, equilateral triangle, 240 volts, 240 volts, 240 volts. This leg was 120. This is a right triangle. And if this is 1, this is the square root of 3. So this is the square root of 3 times 120 is 208 volts. So this is circular triangle. Circular slide rule is just regular slide rule, except it's expanded to much more accurate in the sense that it's about 2 feet long for most of the scales.